For this week, we will discuss about two topics. The first topic is about complex data type, and the second topic is about application development. For this video, we will only discuss about complex data types. And here's the overview of topics that is included in this video. The first is the definition of semi-structured data. Why is there a need for semi-structured data o parang medyo structured data? And then there are two examples that I will give, yung XML type and the JSON type. There's another type of knowledge representation na hindi lang tree-like structure, and this is what we call the RDF. And for the RDF, knowledge representation, you can imagine na parang graph-like yung structure nung knowledge representation natin. And instead of querying using SQL, we will use Sparkle to query information out of this model. And for the mapping between object-oriented programming to persistent type of storage, may tinatawag na ORM. And basically, wala kasing idea ng persistence when you create objects from an OOP. Yung ORM, it allows to create parang database entities automatically. So, in this case, if you're a software developer, hindi mo kailangang maging database administrator. You just need to define the objects. And then we will discuss other types of formats na mostly text. So, these are textual data and yung mga type ng data that describes a space. So, ito yung mga spatial data. Okay, so before we start, actually, hindi naman tayo totally, ignorant sa idea ng complex data type. And in fact, may idea na tayo about composite attributes, and these are attributes that can be decomposed further into component attributes. So, for example, we have name, could be divided into first name, middle name, and then last name. And then, meron tayong other component attributes that can be further divided pa into component attributes na atomic na. So, for street, for example, meron tayong street number, street name, and then apartment number. Okay, so, using an entity relationship diagram, we can describe composite attributes or complex attributes. And given that description, we can create a table that can address those data types. So kapag we have a composite attribute, what we do is that when we create a table, fina-flatten natin yung mga attributes such that all attributes are atomic. And then if attributes have multiple values or a set, for example, in the phone numbers ng instructor, what we do is to normalize the instructor table by creating a new table that can accommodate the contents of the phone number. So, gumagawa tayo ng isa pang table na ang laman ay phone numbers with respect to some ID ng instructor. So, you can store all the phone numbers of a given instructor na may ID na ID. So, question is, why is there a need for a semi-structured data model? Ang main reason is that maraming applications ang nagre-require ng storage of complex data. So, even if you are into modeling the entity relationship diagram, in fact, dito yung marirealize na may some information na medyo mahirap i-represent using just atomic attributes. And may mga cases then that the schema changes often, and especially if you have an application na may mga additional features in the parang version 2, version 3, and so on, sometimes we need to change the schema. So, ano kaya yung way such that hindi masyadong fixed yung structure ng database and at the same time provides flexibility dun sa application. Okay? So, we use semi-structured data models. So, sabi din dito, yung requirement that the data type is atomic, overkill daw yon kasi hindi naman necessarily lahat ay dapat atomic. So, minsan, very appropriate na set yung representation. Sometimes, multi-set yung representation. And then, kapag semi-structured siya, mas madali yung pag-exchange ng objects or pag-exchange ng some information. So, mas napapadali daw yung exchanges between different applications kapag we have a semi-structured data. So, there are two widely used semi-structured data. Ito yung JSON type and XML. So, I provided videos for the JSON type and also provided the videos for the XML type. Okay, so what are the features of a semi-structured data model? May tinatawag tayo na schema na flexible. In the initial phase of our discussion tungkol sa mga relational data models, wala tayong tinatawag na flexible schema. Pero for structured data models, we can have wide columns, we can have sparse columns, and iba yung two types of representation na to. For wide columns, it allows that each tuple have different set of attributes and you can add new attributes anytime. Tapos for sparse column representation naman, you have a very large set of attributes pero yung each tuple mo may store only a subset of the data. So, yung mga multi-valued data types, dito pumapasok yung mga sets and multi-set representation. What is important is instead of creating a new table, we can just store the contents in a list. So, yung katulad kanina na phone numbers, hindi natin kailangan mag-create ng a new table that can store all the phone numbers. For the semi-structured data model, you can just list down the content in something like this. So, parang pwedeng enclose in curly braces. Tapos, yung mga contents ay listed lang doon sa loob ng curly braces na yun. Okay, so meron din tayong tinatawag na key value mapping for a multi-value data types. So, ang pinakamalapit na familiar kayo dito ay yung mga dictionary type. So, yung key niya dito is the brand, for example. Tapos yung value niya is Apple. Key value pair siya. So, ibig sabihin, tuple lang to. One for the key and one for the value. Okay, so, size 13. So, yung JSON object natin later on ay very, very similar to this key value pairs na to. Okay, and then, if we have key value mapping, may mga several operations that we could define. We could take into account yung parang ginagawa natin sa dictionary wherein you put a key with this specific value. You get the value by specifying the key. So, meron tayong get key and then i-return niya yung value. And then you can also delete the key along with its corresponding value. And then there are also type of a semi-structured data model na tinatawag na array. So, kapag array yung type mo, well, it's a sequence of either an integer or a real number. And this type of data is mostly used for scientific and monitoring applications. Okay? So, instead of parang having an array na merong key value pair, like timestamp, tapos value, yung ginagawa for array is just a sequence kasi sometimes itong mga array ay ino-obtain ng mga IoT devices. So, yung mga IoT devices may pre-programmed interval of getting the information or getting some measurements. So, ang ginagawa lang is to keep the representation as lean as possible. So, it's just the listing of the measurements through time. Kumbaga, parang pwedeng ganun yung representation. Okay. So, meron din tayong tinatawag na multi-valued attribute types. So, kung maalala nyo yung requirement ng first normal form, hindi na siya first normal form if we allow multi-valued attribute types. And yung mga ganitong representation, in fact, baka magulat kayo, supported na to ng most database systems today. Okay? So, may mga specific databases na ginawa specifically for this. Meron tayong version ng or variant ng Oracle that is good with array type of data. Ito yung Oracle GeoRaster. Tapos may PostGIS. And then, I think familiar ako dito sa SciDB for scientific um, scientific database. Ginagamit for scientific applications. So, with respect to the type of data, may mga mas appropriate na databases. Yun yung isa sa takeaway natin dito. Okay? So, may tinatawag na mga data types na nested. So, yung mga nested data types, ang form ng data is hierarchical or tree-like. So, yung JSON and XML are both examples of a hierarchical data type. So, yung JSON is equivalent to JavaScript object notation, and it is widely used today, especially with web applications. Whenever there's an object na pinapasa from one component of the system to another component of the system, pwedeng back-end to front-end, front-end to back-end, back-end to back-end, and yung mga exposed as an API, usually mga JSON objects na yung pinapasa. And then, may XML din, which is medyo mas matanda than JSON. Ginagamit pa rin siya today. And if you will open yung mga PDF files nyo, in fact, baka lumabas pa dun yung mga UTF, iba nga, mga readable by human, language, ANSI, na naka-XML format yung mga yun. Especially if you wanted to extract yung mga information from PDFs, usually enclosed pa rin sila using XML to define the format of those documents. Okay, so remember that if you have a document, in fact, parang tree-like structure lang din siya with chapters, with sections, contents, subsections, and so on. So you can describe the file, any type of file using some hierarchical format. So, at the back end, it's just represented using XML. Except for those, like yung mga Microsoft Office na hindi mo na talaga nare-read yung actual content. But for mga PDF, usually readable yung content niya and then represented siya using XML. Okay, so let's start with the JSON representation muna. So, yung JSON representation, if you open it, readily mababasa mo yung content of that JSON file. And meron siyang ganitong formatting. So, the formatting is enclosed by the curly braces na open and close. And then sa loob nito, it's just a list of key value. Okay, so for example, yung JSON object na to ay may key na ID and may value na 222. May key na name, and the name can also be something like a set, multi-set, and so on. So, yung content niya or the value can also be an object. So, in this case, yung children dito is a key, and yung value niya is a set of object na tao din with contents na may key value din. So, first name Hans, last name Einstein. So, pwedeng hierarchical yung magiging key value pair mapping natin dito. So, you can also think of JSON files as just an array of key value mapping. So, yung JSON file nito, for example, is the sequence of key value na ID 222, name, and then the actual object, and so on. Okay, and for the XML naman, totally different sila ng JSON. And ang difference for XML data is that enclosed siya ng mga markup text. So, may mga tags. So, in this example, we can describe the object na course and to describe na ito yung mga attributes ni course, ilalagay din natin siya sa loob ng tag. So, course, tapos enclosed with backslash course to end the definition of course. Yan. So, makikita nyo din na merong key value mapping dito. The key, for example, is course ID, tapos yung value niya is CS101. Hindi nga lang siya katulad ng previous example natin, just like JSON. Okay, so here's another example of a data in XML. So remember, the JSON file and the XML files are all types of hierarchical na data. So represented sila using a tree structure. So to be able to query information that is represented using XML, gumagamit tayo ng XQuery language. So, yung mga SQL extensions, meron din silang capability to support XML. Ang capability is you should be able to store yung mga data types that is in XML format. You can generate or export XML data from a relational data and then extract data from an XML data type using yung mga path expression. So, if you are interested, you can look at chapter 30 for the discussion about this. Before we move on to the next topic, which is knowledge representation, I am showing here two very familiar structures of knowledge. The image on the left side is a tree representation of information, and the image on the right side is a graph representation of information. So, over the years, across different cultures, even in biblical times, humans use the tree structure to represent their understanding of the world. A family tree is used to document their ancestral lineage. Taxonomy uses dendrogram to define the different classifications of living organisms. And then yung phylogenetic tree is used in genomics. Science is a study that is divided into branches. So in the previous example, yung JSON and XML naturally can be viewed as a tree. However, as the information grew a lot more complex over time, the tree representation isn't enough to model the current information or even more complex yung knowledge. A more general representation though is a graph wherein there will be no restriction on connections that forms a cycle. Okay, as mentioned here in this slide, the representation of human knowledge is a long-standing goal of artificial intelligence or AI. And there are several various representations that are proposed over time. And isa nga dun yung relational databases that we know from the first part of CS165. Another type of representation is using RDF or resource description format, and in this format we are using triple to represent information or a fact. So to represent the fact, we will just use the subject, predicate, and object na representation. So for example, if we wanted to say that the winner for NBA 2019 is Raptors, then meron tayong triple na NBA 2019 winner Raptors. And then if we wanted to say na yung capital ng USA is Washington, D.C. Then we have Washington, D.C., capital of USA. So, gusto natin, of course, na makonect yung idea natin about data modeling na ER model or entity relationship model to RDFs. And in fact, if we have an ER model, we can also have an RDF type na structure. And yung mga triples natin, magkakaroon ng two categories. Yung category 1 ay if we wanted to assign a value to a particular ID. So, ang triple natin for that is ID, attribute name, and then ano ba yung value. Tapos, we can also specify that there is a relationship between two entities na may primary key ID 1 and then primary key. Okay, so the RDF has a natural graph representation where yung triples natin are the edge list and the nodes are the subject and the object. So this is an example of a knowledge graph. As you can see, this is very similar to the data structure graph except we have two types of nodes. We have the nodes inside ellipses and we have rectangle nodes, and there are edges connecting them na may labels. To illustrate how the entity relationship model is used here, we can zoom into a portion of this knowledge graph and see that meron tayong 00128 inside an ellipse connected to 102 inside the rectangle to denote mapping ng 102 value sa attribute na total credits for a student na may ID 00128. Okay? So, the second example naman is a relationship between two different entities na may ID ComSci and ID 00128. And this is the relationship na student underscore department. So, if we will go back dun sa table na makikreate mo, if this is for the relational setting, you need to take into account that the binary relationship type, which is one-to-many. So, one department to many students. So, ano bang gagawin natin doon? For the student table, gagawa tayo actually ng department na column. Okay? So, that will represent the relationship. Pero in this case, we will just need to specify that there's a link between ComSci and 00128. Tapos, the predicate is the student type. Or the relationship name is the student type. Okay? So, since this is a graph, and we can represent a graph using the set of all edges or tinatawag nating edge list, we can represent the RDF using the list of all the triples. Okay? So in this example, you can see na bawat edge doon sa graph natin is here in this triple view of the RDF graph, except for some special triples that specifies that a specific ID is an instance of a certain entity. So for example, 10101 instance of instructor, just to specify that that ID is an instructor ID and so on. Okay. So, kung meron tayong SQL for relational databases, for RDF naman, we have what we call the Sparkle. Okay, so for Sparkle, we have a triple pattern na yung example. So, para may question mark, variable name, the predicate, and then some value. So, yung Sparkle queries, meron din siyang select and where. However, yung mga conditions niya ay mga triples. Okay? So, important yan yung may question mark. That's the syntax for the Sparkle. It also supports yung mga operations like aggregation, joins, and so on. However, yung underlying operation nito ay parang reachability in a graph. So, pathfinding and getting transitive closures because it's a graph database basically. Okay, so note that the RDF triples represent binary relationships, di ba? So since it's a triple, dalawa lang naman yung kinoconnect natin. But the question is, how can we represent n-ry relationships or relationships between n objects? Ang sabi dito, we have two approaches. The first approach is we can create an artificial entity na, let's say, E sub 1. Okay? So, ang goal natin kasi ma-represent yung quad na Barack Obama, President of USA 2008 to 2006. Just to specify the fact na si Barack Obama is the President of USA from 2008 to 2006. If we will represent this using approach 1, we need to define an artificial entity na E1 para ma-decompose yung apat na to into 4 triples na nandun lahat si E1 and specify na ano to, parang ID, attribute name, and then value. So, magkakaroon tayo ng E1, person, Barack Obama, E1, country, USA, E1, president from. So, parang tinry mo i-decompose yung n-ray relationship into n triples by creating an artificial entity. So, that's approach 1. For approach 2 naman, gagamit tayo ng special na structure na tinatawag na quads. So, of course, instead na tatlo yung content, magkakaroon siya ng isa pang extra. Pero yung extra na to, special type of entity siya na tinatawag na context entity. So, in this case, naglagay tayo ng context entity na ang value is C1. Okay? So, yung mga remaining parts nung quad natin dito sa taas ay nilagyan natin ng 2 additional triples to add yung information about the president from and president till. Ayan. So, may context entity tayo na C1 dito sa first additional triple and then second additional triple dun sa president till. Okay, so RDF is widely used as a knowledge-based representation. For example, for DBpedia, Yago, Freebase, and Wikidata, RDF yung ginagamit niya. And in fact, merong parang isang project na may vision na i-connect lahat ng mga different knowledge graph para we can query all those information na nag-span from different databases. And yun yung tinatawag nila linked open data. You can search about it sa internet. Okay, for object orientation, I'll just give a short introduction. Before CS165, we're already processing data, which we receive and print to the command line. If we are using object-oriented programming language, we are actually defining objects as entities with certain attributes as properties, so we can handle complex data. However, the data is not persistent, not unless we write the output to a file and read the file afterwards. The advantage of object definition in programming is that we can represent more complex data type and we can specify the relationship between objects through inheritance. So, to merge the persistence of data using a database with complex representation in OOP, we will discuss what we call object relational data model. Okay, so now take note that system applications are often written in OOP languages like Java, Python, C++. However, this object types does not necessarily match relational type, and switching between yung imperative type and declarative type is actually troublesome kasi SQL is in declarative. So there are 3 different approaches now how to integrate object orientation with databases. The first approach is by building an object relational database and then adding object-oriented features like type definition and inheritance to a relational database. And then the second approach is by using what we call object relational mapping or ORM that automatically converts data between yung mga programming language model to relational model. And then the third is building an object-oriented database talaga that natively supports object-oriented data and direct access from programming language. However, yung third method is often unsuccessful daw. So, yung first and 2 methods lang yung i-discuss natin. For the object relational database systems, here we can see that the object-oriented database system can actually define object types like, for example, person, with the following properties. So may ID, name, address, and then you can also create a table out of it. So you can just use create table people, yun yung name ng table of type person. Okay. So you can also create a table directly by saying create table users, blah, 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 blah. So, meron tayong ID, name, and then something. So, yung interests dito is another attribute na ang definition is of type interest as we defined earlier in the parang earlier lines. So, may create type interest tayo, but interest here is a table and the type na ang table contents is topic and degree of interest. Okay, so meron tayong tinatawag na subtable inside a table user. Okay, so another interesting feature in OOP is actually inheritance. For object type definition, we can specify that student is under a person. And that is the case, and if that is the case, then all attributes of person is inherited to the student, and then we can just specify the additional attribute that is needed in the student na hindi naman necessarily nandun sa person. So, for example, we have the degree for the student, we have the salary for the teacher. Okay, so yung second type naman natin of inheritance is the table inheritance. And instead of using under keyword, gagamit tayo ng inherits na keyword to specify na all attributes ng table na people, for example, is inherited to students with some additional attribute na degree. So, ganun din sa teachers. We can create table teachers, additional additional attribute na salary, and then specification that we inherit the contents of the table people. Okay? So, if you noticed, meron tayong dalawang sub-items under table inheritance. The first item is with respect to PostgreSQL. Ganyan siya mag-define ng inheritance. And then the second one is using SQL 1999. For the SQL 1999, we need to specify the object kung saan siya na-map. So, create table people. Okay, so people is a table of the object type person. Create table students of object type student. Under people to specify that all attributes of people is also in students. Ganun din sa teachers. Okay, so the next slide will show how referential integrity is specified in an object relational data model. So basically, we just need to add an additional line that specifies ID as the attribute used for referencing. So when we create the object type person, meron tayong one line ref from ID that will be used for referencing. So suppose meron tayong one object na department, and then this department will later on magiging table, no? And we can say that meron tayong attribute na head that references the person. Okay, so yung ref person dito is an indicator na pwede natin i-assume na head is an attribute na ang lalamanin ay mga ID ni person. Okay, that's for the first approach. The second approach naman is about ORM. So, this ORM is just a system that allows automated creation of database tuples kapag nag-create tayo ng object, and automatically update, delete yung mga tuples ng database whenever yung object natin ay updated or deleted. So, it's a system that is inside the parang framework of programming languages like Java. So, meron tayong programming framework Hibernate, and then meron siyang component na ORM, Hibernate ORM, that does this. And for Python naman, we have Django ORM. So if you wanted to know more about object relational mapping, you can read about it in section 9.6.2. So take note lang din na for ORM, we don't need to provide SQL commands dito. Kasi ang kailangan mo na lang i-utilize ay yung mga creation ng object at galaw-galaw ng mga object na yon using the programming model. Okay, so for our last installation for complex data types, i-discuss ko lang briefly that we have two types pa, the textual data and the spatial data. So, doon muna tayo sa textual data. Yung process of querying yung mga tinatawag na unstructured data is called information retrieval. So, ano ba yung example ng mga unstructured data? These are your comments sa Facebook. These are your Twitter, mga tweets, ganyan. So, kasama din dyan yung mga news articles, reviews sa e-commerce, etc. So, whenever we create a keyword, parang hashtag doon sa mga tweets and comments natin, we are allowing information retrieval using these keywords kasi medyo naive at medyo exhaustive kung yung lahat ng text doon sa unstructured data ay gagamitin for searching. May mga more advanced models like rank relevance. Kinocompute yung rank relevance ng mga documents. And ang crucial dito is that yung keyword mo that is inside the text should be able to capture kung ano man yung content nung unstructured data. So, dun sa relevance ranking, isa sa pinaka-common na technique is the TF-IDF. So, remember that to summarize, let's say, kung ano man yung content nung unstructured data, sometimes ang pinaka-basic na representation nito is just to count the number of words. Parang similar siguro dun sa word cloud na representation. And for each word, of course, meron total number of frequency kung gaano kadalas siyang banggitin. And relevant daw yung certain term for that particular document if madalas siyang banggitin. So for example, if you create a word cloud for all the contents of the book ni Silberschatz's, probably marami dito yung database system. We can compute the total number of frequency and yung percentage nung frequency na yon over all other terms in the document. So, yun yung N of DT over ND. So, yung one definition nito ay naglagay lang ng logarithm. So, pinasok siya sa loob ng logarithm just to get a lower value. But the idea is, the higher the number, the higher yung relevance nung term T to a document, D. Okay. So, may tinatawag naman na inverse document frequency. And yung computation ng inverse document frequency is 1 over N of t, and yung N of t natin dito is the number of documents that contain the term t. Okay, so mas mataas yung value nito kung mas mababa yung N of t. So mas mababa yung N of t, ibig sabihin mas kaunting documents lang ang gumagamit ng term na yun. So, yung relevance of a document B to a set of some terms Q ay yung tinatawag na TF-IDF. And the computation is just the parang product of the TF and the IDF of T for all the terms T. For a given unstructured data, you can get a set of Q that is highly relevant doon sa document mo. And it's a representation of the document itself. So sometimes ginagamit ito to summarize the content of a document na medyo mahaba, just to know kung ano yung keywords if the keywords are not supplied by the author. Okay, so that's for the TF-IDF. And yung pinaka-similar na isa pang application nito ay ranking naman ng links instead of documents. So, yung mga pages, ginagamit din yun to um, represent yung unstructured data, and yung Google search natin basically yung tumatanggap ng mga keywords. And ang gusto natin is to search for relevant documents with respect to the keywords na sinupply natin. So, that's a generalization of the TF-IDF except some minor modifications dun sa algorithm. Okay. Note na maraming possible definition yung TF-IDF, and this is just one definition. Okay, so one way to verify whether your TF-IDF or some information retrieval is good is when you have some sort of a benchmark dataset. Yung benchmark dataset mo na yon, you have a tagging whether it's relevant or not. So, we can actually measure the parang precision of your algorithm with respect to some true value. And yung kaya nating ma-measure is the precision and recall. So, pag mas mataas yung value ng precision, yung percentage of the returned results are actually relevant. Yung recall naman, yung percentage ng relevant results ang nai-return. So, to provide you with a more intuitive definition of precision and scale, we present this figure. Suppose we wanted to obtain all the relevant items inside the false negatives. We wanted to discriminate, of course, yung mga true negatives. And we have an algorithm, na information retrieval algorithm, that obtains a set of elements na nandun sa loob ng circle natin. May mga tama and may mga mali dun sa prediction. And yung mga tama, yung mga totoong relevant items, yung tinatawag na true positives, and yung mga pagkakamali ng information retrieval algorithm naman, yung mga false positives. So, we can compute the precision of that information retrieval algorithm by getting the ratio of the true positives over the cardinality of all the predicted items. So, in this case, meron tayong 5 na true positives, and then the total nung mga na predict natin is 8. So, that's 5 over 8. Okay, so, mas madalas na gamitin yung precision, pero it's not enough to say kung gaano kaganda yung isang information retrieval algorithm. Okay, so yung problem with precision ay it does not capture the total number of relevant items naman talaga na hindi nakuha ng algorithm. That's why meron pang isang metric called the recall. And yung recall naman is computed by getting the ratio of predicted relevant items, so that's 1, 2, 3, 4, 5, okay, over all the relevant items. So, yung percentage ng nakukuha natin out of the dapat makuhang sagot, that's the recall. And may mga scoring metrics pa na nagko-combine ng two metrics na yon, and sample metric ay yung mga tinatawag na F1 score and F2 scores. Okay, so ito na yung last na topic natin for the complex data types. We will discuss about spatial data. Okay, so these are data na may kinalaman sa space. So, this contains geometric elements like yung point, line, triangles, polygon in 2D and in 3D. So for example, we look at Waze or Google Maps. Behind those fancy maps, we actually have geometric elements with metadata like a point specifying a particular place or a polygon describing a certain region. Okay, so this data are called geographic data. So On a higher level, it consists of road maps, land usage maps, topographical elevation maps, etc. And yung mga system that utilizes those geographic data, yung mga tinatawag na GIS or Geographic Information Systems. Sa back-end nito, yung data natin are just 2D, 3D representation of all the information na mas fancier makikita if we will look at the GIS. So, at the lower level, meron tayong line segments which can be represented using just two endpoints. Tapos, we have a polyline or a line string. Sometimes ginagamit to represent roads, which is just a list containing coordinates of endpoints or just a list of line segments. Tapos, we have, in general, a polygon, which is represented by a list of vertices that is in order. Okay, so yung polygons can also be represented as a set of triangles. Yung triangles dito can be represented as a set of line segments naman. Okay, so here's a graphical representation of all those parang basic geographical data. As a line segment, of course, we just needed 2 points to represent a line. So it's x1, y1, x2, y2 in the representation. And if we have a triangle, then we have a set of 3 points naman. Then for the polygon, important sa polygon na in sequence nag-a-appear itong mga to. So we have points na nasa border ng polygon, and then yung region inside the polygon, a certain zone in the GIS. Okay? So, as mentioned a while ago, the polygon can also be represented as a set of triangles. So, dito, we can decompose a polygon into 3 triangles na ang representation ay yung nandito sa right side. Okay? So, we can just add an ID to illustrate that these triangles are the decomposition of a certain polygon.